Hey, this is our next video on graphing rational functions, and this is going to be sample 3. I strongly encourage you, if you have not done your delta maths from Monday and Tuesday before Thanksgiving break, that you do those delta maths. It will make this these problems on your homework packet much easier. So do your delta maths, come back, work your graphing packets. However, I'm going to go over the sample number 3. And remember, the first step that you're going to do is you're going to try to take the rational function and you're going to try to factor it. So I can't factor the top and I can't factor the bottom. So remember, when I have a um, rational function and it doesn't reduce, then I'm not going to have any holes. Remember, holes are points of discontinuity, or the factors from the point of discontinuity that reduces with the numerator. So if this x minus 3 doesn't reduce with the numerator, then it's not going to be a whole, meaning that this point of discontinuity, x can't equal 3, is going to be a vertical asymptote. So it can be one or the other. It can be a vertical asymptote or it can be a whole. It can't be both. And how do I tell the difference between a vertical asymptote and a whole? Well, whether the factor that created the point of discontinuity, that x minus 3, if it reduced with the numerator, because there's an x minus 3 up at top too, then it's a whole. If it doesn't reduce, then it's going to be a vertical asymptote. Now, once you have located all your points of discontinuity, which I only had one, and then you gave it a name, either a vertical asymptote or a whole, then you're done with this section. The next section you're going to do is domain. I quickly know that my domain is everything but my points of discontinuity, the zeros of my denominator. The next thing I'm going to move on to is I'm going to move on to the x-intercepts. So we remember a fraction has a numerator and a denominator. And remember, if my denominator is, my numerator is set equal to 0, then whatever number is in my denominator won't matter. My output will be 0. And remember, that's what I want for an x-intercept. Where is my y or my output? 0. So what really I'm saying is, where is my numerator? What x value causes my numerator to equal to 0? Because as we're looking at here, that's when my y is output as 0. So I'm going to look at my numerator. Now, if it was reducible, I would look at my numerator in reduced form. So I'm going to take my numerator, I'm going to set it equal to 0 and find what x value causes my numerator to become 0, and the answer is 0. Okay, and so I know that I have an x-intercept at 0, 0. Notice if I plug a 0 in for x, I get 0 squared is 0. 0 minus 3 is negative 3. It's not going to be a problem with my denominator. It's only going to cause me to have a 0 in my numerator. So I know when x is 0, my y is 0. The next is my y-intercept. I should know that I have a y-intercept at 0, 0, but if I was going to algebraically try to find it, it is the constants divided by each other. And if you notice, my top polynomial technically has a constant of 0, and it's 0 divided by negative 3, which is 0. Because if I set my x's to 0 to find my y-intercept, all my x terms go to 0, just like a polynomial, leaving me just the constants. Okay, so this is the big part of graphing irrational functions. These A through D, being able to find these is really, you have the majority of your graph already built. I know if I come down to my graph, I have some information I could put in. I have a vertical asymptote at x equals 3. I have an x and y intercept at 0. And now I can kind of starting to put together what my graph might look like. However, I do need to test and see, hey, is my graph approaching to on the right side, is it going up forever like that? Or on the right side, is it approaching and going down forever? So we're going to do a test line. Remember, we don't have to test the holes, just the vertical asymptote. I'm going to put a generic x-axis. I'm not going to worry about my y. And I'm going to put my vertical asymptote kind of just down the middle. It's at 4. And then I'm going to test two values. The right side, I'm going to pick, I don't know why I put 4 there because my vertical asymptote is at 3. And I'm going to pick two values, one to the right of the vertical asymptote and one to the left. So to the right, I'm at 3.001, slightly bigger. So we don't want to say 4. That's too far away. It might give us a false value. So we want to pick really, really close, and then 2.999. Kind of want to make the denominator always either a positive or a negative 1,000. Okay, and now for the right side, I'm going to go to my reduced form of my rational, which I know this one didn't reduce, so it's just x squared over x minus 3. And I'm going to plug this number in for my x's. A numerator, I'm not so worried about a number. I'm just worried if I plug in 3.001, is it going to be a positive or negative numerator? And I know 3.001 squared is going to be positive. And now my denominator is going to be 3.001 minus 3, which is 0.001. Now remember, I could write in fraction form, like let's just say that the top is 9. It's pretty close because it's 3.001 squared. So it's about 9. And remember, 0.001 is the same as 1 over 1,000. So what you keep change flip. So I'm going to have approximately a y output of 9,000. Okay, so I'm going to have a really, really large positive y as I get close. So I know that this one is going up on the right side of my asymptote. So I can come up here down to my graph and say, I know when I'm really close on this right side, my graph is going up. It wasn't negative y, it wasn't a big negative y value being down here. Okay, so now I know my graph is going to somehow come in here somewhere. Okay, I want to do the same thing with the left side. So my left side, I have the x squared and the same x minus 3. So I know if I plug in 2.999 for x and then I subtract 3, I'm going to get negative 0.001. And my top is going to be about 9 again, right? I'm going to square 2.99999, which is approximately 9. And I know I'm going to be multiplying this time by a negative 1,000, which means I would get, a negative 1,000, which would give me approximately negative 9,000. We don't have to write those approximations. I'm just trying to explain that to you. So that means when my x is really close on the left side of that vertical asymptote, my output, my y's are really, really big negative numbers. So I'm going to be going down, approaching in the downward on the left side. Okay. So the next thing that I'm going to look at is my end behavior. How does my graph end off? So what you need to do is you need to find the degree of the numerator and the degree of the denominator. So my numerator was a second degree quadratic and my denominator was a first degree linear. So I know my numerator was greater, and so I'd have no horizontal asymptote, and I have a oblique or slant asymptote. A slant is specifically a linear. So let's take a look at it. And we have to long divide. So I'm going to take my x minus 3 and divide it by x squared. Don't forget I need some zero placeholders. Bring, boop, 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 boop. I was trying to synthetically divide there for a second. Okay, so what multiplies by x to get x squared? That would be x. Get x squared. X times negative 3x is negative 3x. Now I'm subtracting, change my signs. What multiplies by x to get me 3x? That would be plus 3. I don't care about my remainder when I have a slant asymptote or a non-horizontal. My asymptote is going to be the result without the remainder. So it's y equals x plus 3. Okay, so it's a linear asymptote. I can go ahead and graph this. I can go, since this is y equals mx plus b, I know my y-intercept is at 3, 1, 2, 3, and I have a slope of 1. So up 1, right 1. So notice it's not a horizontal, we call it slant because it's a linear and it's just a tilted line. Okay, so this is the line my graph is going to approach, but not cross. Unless, I mean, it can cross. I don't know why I said not cross. It can cross. That's what I'm going to test next. So sometimes, because this is end behavior, sometimes my graph can cross the horizontal or oblique asymptote and approach it from the other side. And we don't know until we test to see if it does. So what you do is you say, okay, I have this function. This one is actually the linear line x plus 3, and I want to set it equal to my function. If it reduces, you'd set it equal to the reduced function. And I want to say, do these two functions intersect anywhere? And if they do intersect my rational function and my slant asymptote, then I know it crosses there because there will be a point there. There'll be an intersection point. So I'm going to solve. And I'm just going to work this out. I'm going to multiply this difference of squares. So I get x squared minus 9 equals, and I'm left with x squared on the other side. Always try to move your variable term first, because it should right away describe whether you're going to cross or not. So I have negative 9 equals 0. My variable terms canceled off. That's not true. So what this is saying is these two functions do not intersect. So they will not cross. So no crossing. So my rational will not cross through this slant asymptote. Okay, in any symmetry work, I'm just going to find f of negative x. So I'm going to plug in negative x for my quadratic. When I do that, anytime I square, I get back the same. And negative x and then minus 3. Now I have an odd first degree, so it stays negative x. Now, if it was just this, right now I have odd symmetry because my top changed, but my bottom didn't. So a positive divided by a negative would be a negative f of x. But since I have this constant term, both of my denominator terms did not change, so this is a neither. So no symmetry. Okay, so the last thing that I'm going to do is I'm going to put my graph together. Notice my test over here in the upper right hand corner showed me that I was up here, so I don't cross this y equals x plus 3 line. We determined that earlier. There was no crossing, so it just must mean it approaches it here. Now, if I did find a crossing, what I was saying before is sometimes your graph will cross the horizontal or oblique asymptote, the slant one, and just approach it from the other side. That didn't happen here because we got a no solution. So it looks like that. Just wanted to point that out though. Okay, and my next one, I know it's down here, and I know my graph is going to approach over here because it approaches asymptotes. So notice it's going to touch that x-intercept or the origin. It won't cross through, otherwise it would come back around and have two x-intercepts. I only had one, and if you remember from polynomials, remember when I solved this, I had two x's, right, in my numerator. So that means I had a x equals 0 occur twice, which is a multiplicity of 2, which means it bounces at the x-intercept. And notice that's exactly what it did here, the rational. It stays true with rationals because rationals are just two polynomials divided by each other. Okay, so work on the rest of your packet, and if you haven't done your delta maths, do your delta maths first, and then come back to the packet. I tell you, you'll spend less time. You do your delta math and then come back. It'll make much more sense. All right, thanks. Bye.